So good afternoon. My name is Ros Sadlier. I'm the CEO and the Chief Scientific Officer of EIT USA. And the eTag device that our company is developing is targeted at comprehensive monitoring of the body after trauma, specifically blunt trauma. Our device has a unique ability to continuously track the state of internal organs, to watch for signs of injury to vital organs such as the spleen, liver, and mesentery. We're focused presently on the trauma transport sector of the market, where we believe it has a great potential to greatly streamline management and triaging. So let's set the scene for the sort of environments this device will be used in. So consider there's an ATV rollover requiring a helicopter or ambulance transport, or maybe an injured military member being airlifted from Germany to DC. In both these situations, we have emergency medical personnel who are strapped for both time and space. They're not usually MDs. Blunt trauma that they may have suffered, such as in a fall, a collision, or a detonation, could actually produce severe injury to internal organs that could not be visible from normal clinical signs. So if bleeding becomes apparent during transfer, it may be necessary to provide a transfusion or to redirect the transport to a facility that can be immediately dealing with that indication. For example, many level 2 and 3 emergency rooms cannot immediately provide a surgical response. And if a patient is already in a level 2 or 3 emergency facility and bleeding develops, there may not be sufficient expertise to recognize this fact. So our solution is based on a technique called electrical impedance tomography, or EIT. This technique is conventionally being implemented using an encircling array of electrode sensors, as you can see here. Most EIT reconstruction methods provide reasonable images of changes in internal organs, shown in these synthetic data here for clarity. Our eTag system, though, has greatly improved on just these standard images using a machine learning approach. We've also gone a little bit further and said, well, if we can do this well, why don't we just throw some of the sensors away? So you can see here how eTag maintains its performance even when you reduce the numbers of sensors. We actually have proof of concept of this idea in animal and human data. Well, so we believe we can go even further and make a compact disposable array that can be slapped anywhere on the body and can provide comprehensive monitoring. Particularly, as well as bleeding status and volume, we also can monitor ECG, heart and breathing rate, and temperature, and that's all made possible through an AI processing core that can produce output for a technician working on a patient at any particular time. So the core idea is that we're producing better data and we're doing more with it. The device is precise, sensitive, and inexpensive. So the demand is potentially very large. I mentioned level 2 and level 3 trauma centers, of which there are thousands in the US, but even more, there are hundreds of thousands of transport vehicles, either on the ground or in the air, including hundreds of military transport planes. You can see on the photo on the right, these military transport planes are very cramped indeed, multiple patients with only a few technicians attending to them. We're also noting that there are over 6,000 emergency veterinary medical services in the US, and these are of interest to us for the same reasons that trauma in humans is of interest to us, is that there is potentially a large market in treating animals who have suffered trauma. It also gives us a window into testing that would not be available with human subjects so easily. The business model we're considering is providing these eTag units and sensors for about $4,000, and also partnering with other vital sign monitoring manufacturers to make compatible arrays. These sensor arrays will come in different sizes for different use cases we're considering, and these array packages will be have a limited lifetime, but will expire after several years unused, and those costs will be around $50 for each sensor array. We'll also, because we are machine learning based, be providing software subscription and maintenance arrangements that should produce a steady stream of income. In terms of the competition and the status quo in this particular market, the main competitors are ultrasound and computed tomography. Both ultrasound and computed tomography only produce snapshots of bleeding state and are either very expensive in the case of computed tomography or require expert interpretation, which is the case for both of these, of course. So we're proposing a portable, non-invasive device that is low cost and can produce many different indications. There are other bioimpedance competitors in the medical marketplace, but most of these devices in the last 4 in our list are really focused on hospital markets and not on portable or even home use. Mentioning home use, there are many growth opportunities for this device. We are currently focusing on low resource environments, veterinary trauma, civilian and military trauma in particular, but there are many indications for hospital use, neonatal monitoring, intraventricular hemorrhage, and post-surgical monitoring. And because we're developing a portable, robust device, there are expansion opportunities into home use. We're looking at hemophilia and end user monitoring and also cardiac output monitoring. The team behind our device combines expertise in engineering, mathematics, business development, and product development. The scientific engine consists of myself, Andrew Duncan, and Milena Espanol, along with world leaders in developing and marketing geophysical devices. This gives us a great range of expertise that we need to develop rugged devices and frame our business structure. We're also currently arranging our tests with experts in the area of veterinary and human trauma, particularly Olivia Braddock and Hans Solin, who are experts, either experts in the use of EIT or trauma surgeons with great range of experience in this very area. We're also starting some talks with Phoenix Fire to see how our products could fit into their management landscape. Our initial product development plans involve fabricating animal and human form factors for our device and the appropriate software user interfaces. And initially, we will perform tests on animal subjects to the point of revenue, also providing us information for the FDA pre-submission process. When we have done sufficient human testing, we plan to enter the regulatory phase with human trials. Our milestones: well, our company was formed in 2022 based on 2 existing patents related to the reduced sensor arrangement. We published a proof of principle publication showing the machine learning approach improvements and initiated patenting based on that. At present, we're updating our prototype, hardware and software. We're anticipating beginning veterinary testing and getting more clinical data in the beginning of next year. Sensor refinement, moving into veterinary use and revenue generation, and then entering the FDA process with a 500K seed round. And then when we obtain FDA approval, we will initiate a $3 million Series A round. Use of funds will mostly a quarter go into R&D, and we believe we've developed a reasonably sensible plan based on acquisition of 1K non-dilutive funding in the near future. So what we're asking for is at present $1 million in non-dilutive funding to generate data needed for further seed rounds, to initiate the regulatory process, to begin generating revenue, and to improve our chances of receiving fast F10K regulatory approval and initiating sales. So in summary, ETAG is low cost, non-invasive, requires little user expertise, provides comprehensive monitoring, has an existing stream of revenue potential, and is underpinned by a team with expertise in all the relevant areas. We believe we can successfully get to market with this highly capital efficient business model. Thank you for your attention.